Hello everyone, welcome back to this video series on clinical SAS ADaM programming. In this video, we will see how to create ADAE dataset for a parallel arm study, adverse events analysis dataset for a parallel arm study. Let's take a quick look at the lesson description on what we will be seeing in this. So we will see the creation of adverse events analysis dataset, which covers treatment emergent flag, start date imputation, end date imputation, pre and follow-up flags, and three occurrence flags. So if you are watching this video as the first video, make sure that you are following my other playlists as well. Here we have a separate playlist for ADaM and a playlist for SDTM and a playlist for TFLs and clinical SAS. So I will leave the links for these playlists in the description of the video. So let us now go to the ADAE dataset specification. So I'm opening the specification. So we have been given the variable name, variable label, and the derivation comment for different variables. So similar to the ADSL dataset specification, if something is coming as a copy variable from SDTM domain, so we are being given the name of the SDTM domain and the raw variable or the input variable from that domain. So here if we see for study ID, use of JD, AE sequence, AE term, AE decode, and AE body system. So all of them are copy from SDTM AE domain. So the convention is written this way. And now we have the derivation for TRT EMFL. So it says if AST-DTC, if ADSL TRT SDT is less than or is equal to AST-DT less than or is equal to ADSL TRT EDT plus 14, then TRT AMFL is equal to Y. So if AST-DTC is in between treatment start date and 14 days plus treatment end date, we'll have to populate this flag as Y. So if we see here, so this variable TRT-EMFL is dependent on ASTDT. So we have not seen the variable ASTDT derivation so far here. So here now, in order to derive TRT-EMFL, we should have had ASTDT derived. So this has a dependency again. So we will have to create ASTDT first and then create TRT-EMFL. So let's take a quick look at ASTDT now. So it says populate using AE.AESTDTC, which means AESTDTC variable from adverse events domain. So which is input variable for start date of adverse event in SDTM adverse events domain. So when AESTDTC is full, it says convert it into numeric format. When only day component is missing, use first day of the month. So it says whenever year and month is present but day component is missing, so we are being asked to impute it with the first day of the month, which means we are being asked to assume it as the first day of the month for analysis purposes. And when month component is missing, which means only year is present, so we are being asked to use the value of January for that. So we will be imputing, assuming that if only year is present, then we will be assuming that that started on 1st of January of that year for analysis purposes. And then it says when full date is missing, it says use treatment start date. So in the cases where the entire date is missing, so we're being asked to assume that the event started on the day of treatment start. So now we have seen the AST derivation. So we jumped through AST-DT from TRT-EMFL. So let's go back to the variable which is immediately after TRT-EMFL. So which is pre-FL. So here it says if AST-DT is less than TRT-SDT, then populate pre-FL as Y. And then FUPFL, so it says if ASTDT greater than ADSL TRT EDT plus 14, then FUPFL is equal to Y. So if we take observe closely, so these three variables, so we are classifying each event as whether it started before treatment or pre-treatment flag, or whether it started within a specific treatment duration, which is treatment start date to treatment end date plus 14, or after that treatment end date plus 14. So none of these three are mutually exclusive. So there is no overlap between these three. So, and all of these three are dependent on the adverse event analysis start date. So, which is derived using AESTDTC and imputing when dates are partial. So we have seen the derivation for it. We are also carrying forward the AESTDTC variable, which is a copy of the same named variable in SDTM AE itself. And then we have this date imputation flag ASTDTF. So here if we see, we have imputed the date value as January or 1st of January or with treatment start date. So we need a flag to indicate whether the ASTDT value present on a particular date is imputed or not. If imputed, what is the level of imputation? Whether we have imputed the full date, that is at year level, or whether we have imputed at month level or only the day component. So this variable ASTDTF takes the values of y, m or d. So we will be populating it as y when if the start date is completely missing or missing or the or missing the year, then ASTDT f is equal to y. Else if start date has month missing, then populate as ASTDT f is equal to m. Else if start date has day missing, then ASTDT f as d. Because we have handled the imputations accordingly here. If day is missing, so we are imputing the day component, and then we are indicating that in this flag called date imputation flag with which will have the values of y, m or d. And then we are creating study day variable analysis start relative day ASTDY. So it says if ASTDT greater than or is equal to TRT SDT, then populate as ASTDT minus TRT SDT plus 1. It looks like there is some truncation here in specification, so I'll try to correct it in the source. But so here uh, greater than, then if it is greater than or is equal to TRT SDT, then populate as ASTDT minus TRT SDT plus 1. Otherwise, we will be populating just as the difference of ASTDT minus TRT SDT without adding this plus 1. So what I have done here is like I have passed the video and then try to correct this derivation logic here which was getting truncated. So else if ASTDTC is less than treatment start date, then populate as difference of ASTDT and treatment start date. And then AE and DTC. So we are populating it as AE and DTC, which is a copy of the input variable. And then we have AE and DT. So it says populate using AE and DTC. When AE and DTC is full, convert it into numeric format. And then when only day component is missing, use last day of the month. When month component is missing and if year is same as the treatment end date, then use the treatment end date. Else if it's a different year, so use 31st December of that year. When full date is missing, use treatment end date as the end date for it. So AE and DTF, again similar to AST we use it to indicate what is the level of imputation that is being done on AE and DT. So if end date is completely missing or the year is missing, then we are populating it as Y. Else if date has month missing, then populate it as M. Else if end date has day missing, then populate as D. Looks like there is a truncation in AE and DY as well. If AE and DT is greater than or is equal to TRT SDT, then populate as difference of AE and DT and TRT SDT plus 1. And then if AE and DTC is less than TRT SDT, so we just take the difference of AE and DT of and TRT SDT without adding this plus 1. So I'll try to correct this post making this video so that it will become live on the website. So for AESER, we are being asked to populate it with a copy of it from the source variable. And then we have a phase variable which says if ASTDT is less than ADSL TRT SDT, then A phase is equal to pre-treatment. Else if ASTDT greater than TRT EDT plus 14, then A phase as follow-up. Else A phase is equal to treatment. And then we have AESEV, which is a copy of AESEV from SDTM AE. And then we have analysis severity, which is ASEV. So if ASEV is equal, if AESEV is equal to mild, which is from SDTM AE. So which is mild, then A7 is equal to mild. If it is moderate, then moderate in prop case in A7. If it is severe, then if AE7 is equal to severe or severity or intensity is missing, then A7 is equal to severe. So it is in the cases where it is mild, moderate and severe, it will be equivalent to our AE7, but the values are in prop case. But in AE7, so if it is not collected or if it is missing in raw or SDTM AE7, so we are being asked to impute it to severe. So AE7 we will leave it untouched with the values of mild, moderate, severe, and if it is missing, we are populating the analysis severity as severe here. And then A7N, so which is kind of one-to-one relationship between A7 and this one. So we are creating a value of 1 when it is mild, and 2 when it is moderate, and severe, and 3 when it is severe. And then we have AE-rel variable, which is a copy of AE-rel from SDTM AE domain. And then we have relationship group, pooled causality group 1. So if it says if AE.AEREL, which is AEREL from SDTM AE domain, is equal to not related or unlikely related, then we are being asked to populate the value of not related in rel group 1. Else if AEREL is equal to possibly related or probably related or definitely related or causality is missing, then rel group is equal to related. So which means, so here we are, even when the relationship is not collected in the ADTM AE domain, so we are imputing it as related, and along with that, so we are grouping possibly related, probably related and definitely related to related in this rel group 1. And then rel group 1 is a one-to-one relationship numeric variable associated with rel group 1. So here we are being asked to set to 0 when it is not related and a value of 1 when it is related. And then safety flag, we are carrying forward it from ADSL dataset, ADSL.saffl. And then we have three occurrence flags. One is first occurrence within subject flag, and first occurrence within SOC flag, first occurrence of preferred term flag. So let us now see how these variables are derived. So we know that a subject may experience one or more events, and each of those events could be part of any of the system organ classes. So when creating the tables, what we do is we count a subject only once for overall row and only once within each SOC and only once within each preferred term. So we are trying to create these occurrence flags at that level. Subset ADAE, so we are now seeing the derivation for AOCCFL. It says subset ADAE to treatment emergent adverse events. So we are being asked to consider only the records where TRT EMFL is equal to Y, and then it says sort by subject ID, analysis start date and sequence number, and flag the first record within each subject. So out of all the treatment emergent events, so we are flagging it on the earliest record when sorted by subject ID, date and AE sequence. On that first record of each subject, we'll be populating it as AOC CFL is equal to Y. And then we have AOCC SFL. This S stands for SOC. So it says subset ADAE to have only treatment emergent adverse events, and then sort by subject ID, system organ class, analysis start date and sequence number, and flag the first record. So within each subject and SOC. So we'll be flagging if a subject has multiple events within the same SOC, we'll be flagging it on the first record of that SOC. And then we have AOCC-PFL, so which is first occurrence of preferred term flag. So the derivation says again use the treatment emergent records, sort by subject ID, body system, and then preferred term followed by start date and then sequence number, and flag the first record within each subject, SOC and PT. So if a subject experience same event with the having preferred term, same preferred term, then multiple times, then we'll have to flag it on the first occurrence. Say for example, if the subject experienced headache twice or thrice, so we will be counting at subject level only once in our downstream tables. So we are being asked to populate it as Y only on the first occurrence, so that we will be able to easily fetch the subject count. And then TRT-A, it says it is direct copy of TRT-01A from ADSL 01A. And then TRT-01AN, so it says 1 for drug A, 2 for drug B. Again, it is a copy from our ADSL dataset. So and then we have TRT SDT, so we are being asked to fetch it from ADSL dataset. Similarly, TRT EDT, age group 1, sex, and race variables. All of these variables are coming directly from ADSL dataset. So we have seen that in some of the derivations, we in fact need these variables as part of the derivation. TRT SDT is needed for and TRT EDT is needed for TRT EMFL derivation. So we will now move to the programming for this. So here on the left hand side, I have my SAS program, and on the right hand side, I have my input dataset and all the intermediate datasets that are getting generated as part of this code. So like in previous videos, I have my input data required for this lesson stored in a SAS program, and I am including that SAS program in this program. So when I run this line of code, the entire code that creates the input datasets for this lesson gets generated in the work library for this lesson. So let's now move to the programming aspect. So here we are reading and processing input datasets. So the main input dataset for this is our STTM AE domain and ADaM ADSL. So we are sorting AE and creating a dataset called AE01. We are sorting the dataset based on the values present in study ID and useObj variable. And then we are doing a similar sorting for ADSL based on study ID and useObj, and then merging AE and ADSL dataset. Because we need some variables from ADSL dataset, we are merging ADSL to this. At the same time, we are only keeping the records for all the subjects who are present in both ADSL and SDTM AE domain. So we are making use of that using this if statement, if A and B. So we are calling this dataset as AE02. Now we have all the variables from ADSL obtained into SDTM AE. So this becomes our base dataset. AE02 is kind of becoming our base dataset for a subsequent derivation. So we have fetched the variables which are part of, again, let me quickly show you the ADSL dataset for this example. So I have only kept the required variable that will be used for this ADAE domain. So I have dropped all the other variables. So let's see how we are creating the derived variables in ADAE. So we are using our AE02, which has the variables from ADSL and all the variables from SDTM AE, and creating a new dataset called AE03. So we are now creating ASTDT and dependent ASTDTF. So we have seen the specification for ASTDT. It said when the date is full, so when length is 10. So we are directly asked to convert that into numeric format. So we are creating ASTDT by converting AESTDTC to numeric format using input function and YYMMDT 10.in format. And then else if missing of AESTDTC, if the date is fully missing, so we were asked to impute it with the value present in TRT SDT variable from ADSL, so which we have fetched from ADSL in the previous step. So we have TRT SDT available now. So as per the specification for ASTDT, so when AESTDTC is completely missing, so we are assigning TRT SDT to ASTDT. So as we are imputing the full date here, so as per the specification, so we will have to populate the ASTDT F, which is imputation flag for analysis start date as Y. So we are creating that here in the same step. And then else if length of AESTDTC is 7, which means the only year and month is present but day component is missing. In that cases we were asked to use the start day of that month for imputation. So what we are doing here is when it is 7, so we are concatenating 01 to the AESTDTC value and then converting it into numeric format using input function and then YYMMDD10 dot. So we are imputing it with 01. So as we are imputing the day component, so we are flagging it with D in ASTDTF. And then when only year is present. If only year is present, the overall number of characters in AESTDTC will be 4. So when it is 4, so we are imputing it with January 1st. So it is 0101. So we are temporarily concatenating 0101 to the existing year value in AESTDTC and then converting it into numeric value using input function and YYMMDD10 dot. Say for example, if we only had 2010 in AESTDTC, the length would become 4. And then for that 2004, we are concatenating -01 -01. So it becomes 1st January of 2010. So then we are converting it into ASTDT. As we are imputing the at the max level, we are imputing at month level. So we are asked to populate with the value of M in ASTDTF. So we have now completed the derivation for ASTDT and ASTDTF as per the specification. And then we have AENDT and AENDTF. So let's now see here if length of AE and DTC is equal to 10, which means when full date is present, so we simply need to convert it into numeric value using input function and then YYMMDD 10.in format. If it is completely missing, we were asked to populate it with the value from TRD EDT. So we are doing that. As the complete date is missing here and the imputation is coming at year level in the maximum, say the highest component that we are imputing here is the year. So we are populating it AENDTF as Y. So which is date imputation flag for analysis end date as Y. Else if length of AE and DTC is 7, so we were asked to populate it with the end date of that particular month. So here we are using some kind of complex manipulation using int_x function. So the first argument for int_x function is the interval, so which is month. So and then we specify the start date and then we tell the increment and when we tell what is the end date. So if you are looking for a complete explanation of this function, I might have done the videos, so you can examine it in my ADaM playlist or SDTM playlist. So here, so I'll try to quickly explain here. So what we are doing here is when only day is missing. So what I'm doing is here is I am temporarily creating the start day of that month. So when day is missing, so I am concatenating 01 to that month and then converting it into a numeric date because int_x function accepts only numeric date values. So I am temporarily passing the start day of the month as first day of that month. Say for example, if I had the value of 2010 July. So I am converting that 2010 July to 1st July 2010. And then I am telling that increment it to the 0, which is within the same month, but I am asking it to return the end value of the same month. So what happens is, so as this 1st July 2010, same month end date. So it would give me the value of 31st July. Say for example, if it has a value of June 2010-06. So this temporary date will become 1st June 2010. And then I am asking it to present the in the same month without incrementing it by anyone. When I say 0, it is within the same month, but I am asking it to return the end value within the same month. So it knows by default that in the year 2010 in June the end date would be 30. So it would return me the value of 30. So this line of code gives me the end date for each month, irrespective of whether we don't need to check whether it is Jan, Feb, and so on, whether it is a month which has 31 days or whether it has a year with leap year or where we have to populate 29 for Feb or not. So this single line of code handles all of those things. So otherwise, I'll also try to, if I have not made a video on this, I'll try to create, explain this code in detail. Uh, I think I might have done this video as part of date imputation series in ADaM itself. I'll try to leave the link of that video in the description. And then if only year is present, so we were asked to check whether that year is corresponding to the end date of that treatment year or not. If it is the case, so we were asked to populate it with the treatment end date. So here what I was doing is I am extracting the year component from treatment end date and then populate and convert it into character, because I wanted to compare it with the character AE and DTC. So I am extracting the year component from TRT EDT, which is a numeric variable. So I am employing year function, so which returns me the year value in numeric notation. So, and then I am converting it into 4 character wide string using put function and storing it in TRT EY. So here I'm checking if length of AE and ETC is 4, which means only year is present. And if that year is equal to the end year of treatment end date, I am populating it with the value of treatment end date in AE and ET. Otherwise, I am using 31st December as the end date for that adverse event. So here, say for example, if the end date is 2020, so I am concatenating -12 -31 to 2020 and then converting it into numeric format, and then assigning the imputation flag as M, because we are at the highest level, we are imputing the month. So here both month and year date are being imputed, but the highest level of imputation will be indicated in AE and DTF. The highest level of imputation that is being done is at month level here. So we are populating the value of M. And then we are populating TRT EMFL, pre-FL and FUPFL. If TRT EDT not is equal to missing, then we are creating a variable called TRT EDT 14 by adding 14 days to TRT EDT. So we have seen that we needed to check whether an adverse event is in between treatment start date and 14 days of treatment end date. So temporarily I am creating this variable called TRT EDT 14 to capture that 14 days time point till after treatment end date. So if missing less than TRT SDT less than or is equal to ASTDT less than or is equal to TRT EDT 14, so which indirectly means that it is TRT EDT plus 14. So I am making use of this temporary variable that I created to create TRT EMFL. So and populating TRT EMFL Y based on the condition provided in the specification. And then if ASTDTC was less than TRT-STT, we were asked to populate pre-FL is equal to Y. So we are doing that here. And then if ASTDT is greater than TRT-EDT 14 greater than missing, then FUPFL is equal to missing. So in all the cases where ASTDTC is after 14 days of treatment end date, so we are populating FUPFL as Y. And then we are creating analysis variants of severity. So here, if missing of AE severity, then we are populating it as ASEV is equal to severe. Else ASEV is equal to prop case of AESEV. So we have seen in the specification that where the values in AESEV could be like mild, moderate, and severe in uppercase. But for analysis purposes, we wanted to present it in proper case. So we were making use of prop case function to achieve that. And we also had that additional requirement where if AESEV is missing, then we were asked to populate ASEV as severe. So we are doing that here. And then we are creating our ASEV n variable, which is numeric variant of ASEV variable. So for mild, we are populating ASEV n A severity n as 1, 2 for moderate and 3 for severe. And then we are creating rel group 1 and rel group 1 and variable. So rel group 1, if we take a look at this one, so it says if missing of AE rel, then so we were asked to directly impute it as a related. So if AE rel, the input variable, has a missing value, then we are populating it as a related and then assigning the value of 1 for rel group 1 and because they are sharing one-to-one relationship. And otherwise, if AE rel is not related or unlikely related, we were asked to populate it as not related, and we were asked to populate a value of 1 for not. I think I switched this. Let me check the specification. Um, For not related, it should have been 0 as per the specification. Looks like there is an error in the program. I'll try to correct it post this video. For not related, it should be 0, and for related, it should be 1. So I'll try to switch this post this video. So, but as per the specification for not related, rel group 1n has to be 0. And then we are assigning the value of related for possibly related, probably related, and definitely related into rel group 1 variable. Similarly, rel group 1 will also be created. And then we are creating TRT-AN and TRT-A, which were copies from ADSL TRT01AN and TRT01A. And then we are creating our A phase variable. If treatment adverse event start date is less than treatment start date, we were asked to populate it as pre-treatment in A phase variable. And if adverse event start date is within treatment start days and 14 days of treatment end date, we were asked to populate it as treatment. So we are doing that here. And then if the adverse event start date is after 14 days of treatment end date, then we were asked to populate as follow-up. So we are doing that here. So let's take a quick look at A03 and then see how the newly created variables are getting populated. So we have pre-FL populated, TRT-MFL populated, and FUPFL populated on one of the records, and we have ASEV created, ASEV-N created, rel group 1 created, 1N created, treatment AN created, TRT-A, and then uh, A03, where did we create study day variables? A03 has ASTDY and AENDY created. So let's see if we are creating somewhere down the line. So I didn't have the latest code loaded here in this screen on the left hand side. So what I have done here is I have paused the video and I have loaded the latest video. So if we were at the stage of looking at ASTDY and AENDY. So these are the two lines of code that creates my ASTDY and AENDY using ASTDT and AENDT respectively. And then in this, when trying to load that latest code, I have also corrected the rel group 1 and issue which we have noted for not related. I am assigning the value of 0 for the numeric variant and 1 for related variant. So let's scroll down and then is coming to our section of occurrence flags. So here we are trying to create the first occurrence flag within each subject. So we are subsetting the records for treatment emergent adverse events and then creating a temporary data set called AOCC01. And then we were asked to sort the data based on subject ID, start date, and sequence. So we are sorting it using sort procedure by specifying the mentioned variables on by statement. And then we are creating a new data set called AOCC02. So here, if we are indicating to the data step that the observations are sorted based on study ID, subject ID, ASTDT, and AE sequence. And then we are filtering the first record within each subject. And then on that first record, AOCC-FL has to be Y. So we are assigning the text Y to AOCC-FL. And then we are only keeping the required variables of study ID, U subj ID, AE sequence, and AOCC-FL. So we will be making use of these by variables of study ID, U subj ID, and AE sequence and back merge it to the parent dataset AE03 to populate AOCC-FL. And then for AOCC SFL, so we were asked to use the treatment emergent adverse event, but pick the first record within each body system. So we are sorting the data based on study ID, U sub ID, AE body system. So if there exists more than one row within a body system, so we were asked to sort by ASTDT and AE sequence and then filter the first record within each body system of each subject. And then we are assigning the text Y to AOCC SFL and then keeping the required variable study ID, use sub JD, AE sequence and AOCC SFL. And then similarly, we are doing the processing for preferred terms. So we are sorting the records based on study ID, use sub JD, body system, decode, AST, DT and sequence. And within each uh, decode, we need to select the first record. So we are selecting if first dot AE decode on that first record. So we are assigning the value of AOCC PFL is equal to Y and keeping only the key variables that will be used to identify the parent record. So in SDTM AE domain, so we know that AE seq will be unique within each subject on a particular row. So we are making use of that AE seq variable to identify the parent record. So study ID, use sub JD, AESEQ and AOCC PFL is kept. The three variables are now present in three different datasets: AOCC 02, AOCC S02 and AOCC P02. So we need to fetch this information back into our parent dataset, which is A03. So we are sorting the data based on study ID, use sub JD, sequence on all the parent dataset and the three intermediate datasets which have the variables, and then merging it onto the base dataset. So we will have all those three variables coming into the dataset AE04. Let us take a quick look at AE04. So we have AOCCFL, AOCCSFL and AOCCPFL populated accordingly. So this is how we can program ADAE dataset. Maybe okay. In the last step, what we are doing here is creating a macro variable to store the list of variables that have to be kept in the final data set and in the required order. And then we are making use of that macro variable here on the retain statement, so which orders the variables in this order. And then we are keeping the list of variables using keep statement. So in ADAE, we'll only have the required variables which are part of the specification, and then they will be ordered in the same way. And at the end, we are sorting the records based on study ID, use sub JD, start date, AED code, and AENDT. So let us take a quick look at the final ADAE dataset. So we have all the variables which are specified in the specification, and they are also ordered in the same way as per the specification. So we have completed ADAE programming. So this is how we can program ADAE dataset for any study. So again, note that the derivation logics provided here are very study specific, and these may vary a little or a lot from study to study. Thank you for watching and keep learning.